Okay, going to go through question 14 that I started going through the other day, just to make sure that you all have a good understanding of it for those of you who I wasn't making sense to. So we're finding the value of k for where k is a real number, for which the curve with the equation of y equals the natural log of x intersects with y equals kx squared exactly. So to give you a visual aid, I've given you a drawing of, this is the x squared graph, and this is the natural log of x. So this one's not obviously changing, because that's got no variable, but this one is being stretched or squashed, whichever way you want to think about it. So this one is going to look something like this in order for it to touch once. So it's only got that one point where it touches. Now if it just touches once, that means that what's going to happen, and we'll be dealing with this a little bit more next week, is that it's going to have a line, a tangent that has shares the same gradient at these 2 points. So tangents is something we're going to be talking about a bit more later on, so it might be worth you listening to this later on. But it's going to share this common tangent. So this tangent's got a gradient, and at this point here, the natural log of x is going to have the same gradient as the tangent, and then the quadratic is also going to have the same gradient. So what we're going to do is we're going to start off, and I'm just going to label them with g of x and f of x so that we can see the difference by differentiating both of them. Okay, so g dash of x, we should all know is just 1 over x, and then if we call the other one f of x, and so when we differentiate f of x, we end up with 2 lots of kx. So what we want to do is we want to find this x coordinate here that gives us the gradient, gives us the same gradient, so finding an x value. So we want to set the two equal to each other, so the two gradients are equal. So I'm multiplying through by x, and then I'm going to divide through by my 2k, and that gives us our x squared, and then we just want to square root it. So x is equal to the square root of 1 over 2x, which can also be written as 1 over the square root of 2x, by square root in the top and the bottom, but the square of 1 is just 1. So that's our x value. That's the value where the two are going to intersect, if they just intersect once, so they share the same gradient at that point. Now what we're going to do is we're going to find the y coordinates of them. So the y coordinate of g of x first. Okay. So we're just plugging in 1 over root 2x into our equation, and there's not a lot we can do with it. Oops, it's okay, sorry. There's not a lot we can do with it, so that's pretty much all it is. So we know it's got to go through this point, but when we put it into our f of x, we end up with k lots of 1 over root 2k squared. Okay, so this is our x value. Now, in order for them to intersect and share that gradient, that means that these two must be equal to each other, because they're the y coordinates. Well, if they intersect at the point where x is 1 over root 2k, then these two must be equal to each other. Okay, so that means we're going to set the two equal to each other. So now we're going to do the natural log of 1 over root 2k is equal to k lots of 1 over root 2k squared. Okay, because they're both the y values. Well, if they intersect at the point when x is equal to this, then those two y values must be exactly the same as well. So that's going to help us set what k is. Now we can make this one look a bit pretty, so if we square the 1 and square the 2k, then we're going to end up with, I'll just leave this one on its own, just put it in brackets, don't know why. So we end up with 1 over 2k when we take out the square, and then the k's cancel, so we just get left with a half. Okay, now all our aim is now to find out what k is going to be. In order to make those two intersect, is we've got to then make sure that we undo it and have k on its own. So we end up with 1 over root 2k is equal to, so the inverse of the natural log is e, I'll put them half there. So we end up with e to the half, and then we're going to multiply by our root 2k, and then we'll divide through by our e to the half. But remember, by dividing through, that makes this a negative power. Okay, and then we've still got our root 2k. Then we're going to square both sides, so if we square our minus a half, remember that power of power you end up multiplying. So we then end up with, this is just going to be e to the negative 1, and then we've got to divide through by 2, so we get a half e to the negative 1. Okay, and then if you want to make it look pretty, because we've got a fraction here anyway, we might as well just do 1 over 2e. And because it's got a power of 1, you don't really actually need the power there. It's like saying 2 to the power of 1 or 10 to the power of 1, it's just 10 or 2. So that's our k value. So in order for them to intersect at one point, k has got to be 1 over 2e. And then they will intersect at one point, which means they share that gradient. So we'll be talking a little bit more about tangents at the end of next week.